Well, hello class. Today we're going to talk about simplifying radicals. You had a brief introduction to this before, so we're going to continue with this. Remember, to be simplified, there's no fractions in the radicand, which is a thing under the square root. So for example, if you had 10 under the square root, 10 would be the radicand. There's no perfect squares in the radicand, or a factor of the radicand. And there's no radical denominators. The main thing we're going to be doing is looking for perfect squares. Okay, we're going to try to simplify. So if you recall, we talk about if you have two numbers that can be multiplied, say like square root of 6, this can be broken up into square root of 2 and the square root of 3, which could also be written as this. Because it's multiplication, you can write it as a square root of each individual part. So that's the main focus for this. So let's say you want to try and break them up and get rid of the perfect squares. Let me review again perfect squares. Remember, perfect squares are numbers that when you take the square root, you get a whole number like this. Square root of 25 or the square root of 49 is 7. I had you write a list of them. Square root of 100 is 10. Your answer is a whole number versus like the square root of 13. That's going to be some crazy decimal. Okay, I don't even know what it is. Square root of 64, that's a whole number, 8. These are perfect squares, 64, 100, 49, 25. Those are called perfect squares. So we're trying to get the perfect squares or any factor of these numbers that are perfect squares. So for example, if you think hard enough about this, you would come up with the square root of 25 and the square root of 2. And I encourage you to please keep your work nice and neat and organized. Write these together on the same line. Don't have some higher and some lower. But write them together on the same line. So the square root of 25 is a regular 5. That's a perfect square. And this is still a square root of 2. You can't break that down anymore. This is your answer. So you've eliminated the perfect square out of the factor of 50. These are factors, 25 and 2. You made one of them a perfect square. You got rid of that perfect square. So now it's a whole number. If you think hard enough about this one of the square roots, perfect squares is 16. So 16 times 2. Square root of 16 is a regular 4. It's just and 2. Okay. Once again, if you think hard enough about this, maybe you came up with 4 and 5. So the square root of this is 2. And this doesn't break down anymore. So that's it. That's your answers for those. Okay. I'm going to give you a few examples, then we're going to go over a couple of problems. So this is very similar to problems you have in questions 1 through 10. So there's a trick. Sometimes you can't think of the perfect square right off the top of your head. So a trick is 2 of the same thing as a radicand makes 1 with the outside. That's not very clear at all. I didn't write that very well. So let me try to clarify. 2 are the same thing. So maybe you didn't recognize that this is 25 times 2. Maybe you said it was 5 times 10. Okay? Oh, sorry about that. Let me clean that up a bit. So you recognize this is 5 and the square root of 10. The square root of 10 can break down even further to the square root of 5 and the square root of 2. And this is what I was saying about keeping your work nice and neat. You don't want some higher and some lower. So let's just go ahead and bring this down so it's all at the same level. They stay even here. Keep your work organized. So what I was trying to imply up here is 2 of the same thing underneath the square root. So both of these are underneath the square root. They're the same thing. It makes something that's 1 without the square root. So it's just a regular 5. There's only one of them without a square root. The reason is because square root of 5 times square root of 5 is square root of 25. The square root of 25 is a regular 5. So this answer, this doesn't break down anymore. It doesn't have anything else to match with. So this is your answer, 5 square root of 2. Maybe you didn't recognize that the square root of 32 could be broken down into 16 and 2, and instead you recognize 8 and 4. Square root of 8 can break down into 2 and 4. Let's keep this even on the same row. There's 2 of the same thing. That makes a regular 4. So you'd have a regular 4, square root of 2. You'd have the answer up there. Make sure your whole number is always in front. Maybe you didn't recognize this as 2 of the same thing. You just recognize this could be a square root. It's a perfect square. So it's 2, 2, and a square root of 2. These are regular whole numbers. You multiply them together. So you get 4 from those 2. They are in front of the square root of 2. So, sorry, I'm going to space down there at the bottom, but it should look something like that. These 2, multiply them together. So the things outside of the square root get multiplied, and the things under a square root get multiplied. Okay, so maybe you didn't recognize this could be 4 and 5, and you chose 10 and 2. But that could be broken down to the square root of 5 and the square root of 2. We're going to write this down here so it's all on the same level. Okay, you got 2 of the same thing right here. That makes a regular 2. Okay, try to keep in mind, every time you see 2 of the same thing under a square root, it's going to be a regular number without a square root symbol, is what I mean. Okay, so then this doesn't break down anymore, so it's the square root of 5. Okay, just like up here. So you don't necessarily have to think of a perfect square, it'll just save you some time. So you just keep breaking them down until you find 2 of the same thing, and that will make a regular one without a square root. That is basically taking out a perfect square. Focusing on this middle idea right there. Okay, so I'm going to work a couple of examples with you. Let's say you did question number 1 from your worksheet that you're supposed to have. Okay, so question number 1, 24. You might think of a couple of different ways to break this down. Maybe you're thinking 12 and 2. That's 24. Maybe you're thinking 6 and 4. That's 24. Okay. Let's say you did 12 and 2. I imagine since this is even, maybe some of you recognize that one at first. 12 breaks down into, what does 12 break down into? Well, some people are probably thinking 6 and 2. Bring this one down so it's on the same row, please, and they're all even. Maybe you were thinking 3 and 4. 4 is a perfect square. That would be a great way to go. Doesn't matter how you go about it, you can still get the same answer. 6 would break down into 3 square root of 2. Keep this on the same level. Don't forget it. Bring it down with you. These all have square roots. Please write the square root symbol. Every time you see 2 of the same thing, so here's one of them, there's another one, that makes a regular 2. This one doesn't match with anything. It's all by itself. This one's all by itself as well. So you're left with the square root of 3 and the square root of 2. I'm just bringing them down so they're all in the same row. Okay. This doesn't break down anymore. This doesn't break down anymore. It doesn't have a pair to make it a regular 2. This doesn't have a pair to make it a regular 3. So we're just going to multiply these two things together and make the square root of 6. The whole number 2 comes out in the front. This is your answer. Okay. There are several other ways to get the answer. Maybe you did, instead of that, you did the square root of 6 and the square root of 4. If you happen to recognize a perfect square to begin with, this makes a regular 2. You got a square root of 6. The regular number should be on front in the square root, in front of the square root. Always try to make that whole number in front of the square root. The stuff without the square roots is in front, and then you put the square root stuff together behind it. Alright, so same idea. This is number 4. Maybe you recognize this breaks into square root of 6 and a square root of 2. Okay, so you can follow this path like you were doing before. Okay. 3, and this will break down into 2. And you got this one, square root of 2. So this makes a regular 2, and then you've got the square root of 3. Or you did the square root of 3 and the square root of 4. This includes a perfect square. So if you were thinking of perfect squares, it'd save you some time. This makes the regular 2. Actually, I'll do it like this so as not to confuse you. Okay, this makes a regular 2 right here. 2 without a square root. And this is the square root of 3. Put your whole number first, so it's 2 square root of 3. That's it. I know I'm going kind of fast. I'm sorry. You can view this video on your own. Go to McWilliams Math at YouTube. It's all one word when you type it in a YouTube search. And you can search for this video and watch it yourself. Okay, so you got a couple answers for your worksheet right there. Let's try a couple more. So let's do questions number 11 through 20. You simplify with the numbers in front. So basically you're going to do the same thing and you just times this. This is timesing -2 times the square root of 36. Maybe you happen to recognize right up the front that the square root of 36 is 6. So it's -2 times the square root of 6. I'm sorry, -2 times 6. That makes a -12. That's it. You're done. Some people might not have recognized that, and so instead of doing 36, they broke it down, square root of 6, square root of 6. It's 2 of the same, makes a regular 6. There's no more ways to break that down, and you got that regular whole number right there. Number 13 says negative square root of 12. You can imagine this being like a -1. So -1 times the square root of 12. I already did the square root of 12 on this other one, number 4. Let's try it again. It would save you a lot of time and effort if you can come up with a perfect square as one of your factors. So you got negative 1 times the square root of 4. This is why it's important that you write the square root symbol if it has a square root symbol. This one doesn't. You don't want to mix these ideas up. Now this will become a regular 2 without a square root symbol. So negative 1 times a regular 2 times the square root of 3. Negative 1 times 2 makes negative 2. Square root of 3 doesn't break down anymore. This is your answer. Next page. Let's say you're doing questions 21 through 36. Go ahead and skip ahead. Or maybe the sub pause for a little bit and let you work on some of those questions on the previous slide. The question is 21 through 36. Let's start with number 22. Square root of 100 a to the third. So you got some variables in it this time. You're still going to break them up like you normally would. If you didn't happen to recognize that the square root of 100 is a perfect square, then you might start breaking it up 10 and 10, or maybe to 20 and 5 or something. Eventually you should come up with a regular number of 10. I'm going to break this up into two different things. This is a multiply. This is that very first rule I showed you, that when you have multiplication, you can break it up, and so each part of that has a square root. So this is all multiplication. 100 times a to the third, each part of that will have a square root. Now, as I was saying, every time you have two of the same thing, it makes a regular letter, variable, or number without a square root. So these two are the same. Square root of a, square root of a. Two of the same makes one without a square root. This one doesn't have another square root of a to match up, so it's going to be left under the square root. These are two numbers without square root. They get multiplied together, so it's 10a on the outside and square root of a. Okay. So a to the third means you're going to do that 3 times. Two of those will make a regular a. Multiply it with a regular whole number out here, stuff without a square root. And those we come together and times it by the stuff under the square root. Same idea here. We done 20. Did we do 20 earlier? Maybe we did. There it is. 20. It ends up being 2 square root of 5. Okay. Once again, try to think of perfect squares. Square root of 4, square root of 5. This is square root of r, square root of r, square root of r. This is a regular 2. Square root of 4 is 2. Or if you broke it up, square root of 2, square root of 2, it's 2 of the same thing, makes a regular 2. This doesn't break up to anything. For 2 of the same, you get one without a square root. So this is a regular r, no square root. This still has a square root because it doesn't have anything else to match up with. Square root symbol, sorry, square root kind of looks like an r. So this is without a square root, this is without a square root. Put those together, 2 times r. This has a square root, this does have a square root. Put those together, both under a square root. So square root of 5r. This is your answer. Question number 30 looks like that. For every 2 of the same thing under square root, it creates one without a square root. The rest are all just a combination of what we've just been talking about. Okay, so you got a variable underneath, you're breaking down the number, you're multiplying by the stuff in front. Okay, so this is 2 times the square root of 64 times the square root of m, if I broke that up. Maybe you happen to recognize right off the bat that the square root of 64 is just 8. Square root of m doesn't break down anymore, so you're going to leave it square root of m. 2 times 8 is 16. So this is 16 square root of m. Okay. Hopefully that's enough information to help you out with the rest of these. Okay. Maybe I'll try one more of those combinations. How about question number... I'll go ahead and do 38. I want to leave you some to try on your own, but I'll do 38 for you. 6 square root 32a to the third power. Okay, I'm going to break it up into each of the parts. 6 times the square root of 32 times the square root of a to the third. Square root of a to the third is square root of a times square root of a times square root of a. 32 could break up into 8 and 4. Could break up some other way. 16 and 2 would actually be a little bit better. And then you got the 6. So I'm trying to keep it all even. I brought this down and broke that all up. Okay. I'm going to break this up some more. 8 breaks up into, what are you thinking? Hopefully square root of 2, square root of 4. Make sure you include your square root symbols. Bring this one down. As you see, there's 2 of the same. That makes a regular 4. Or maybe you made this a 2. Square root of 4 is 2. And this is another 2. So if you did it like that, it would look like this. 2 times 2 is a whole number of 4. These don't have square roots anymore. The square root of 4 is 2. Square root of 4 is 2. 2 times 2 is 4. So this is 4 square root of 2 just for that part. Okay. I'm going to bring this down. That's a 6. 6 times the square root of 4 times the square root of 2. For every 2 of the same thing under a square root, I get a regular one without a square root. This one doesn't have another one to match up. So I'm just going to bring this down. Got times an a and times the square root of a. I'm showing you every little single step. You guys might be able to skip a couple steps once you get pretty good at this. All the stuff without a square root multiplied together. 6 times 4 is 24. Times an a is 24a. All the stuff with a square root, put it together. Square root of 2, square root of a. So I'm going to put square root of 2a. There you go. That's your answer. Please don't just copy down. I know you don't have a lot of space in between these problems. But do the best you can. You can do it on your own sheet of paper if you want, but I want you to do the best you can, do as many as you can. We'll talk about it when I get back. All right. Good luck.